Bismillah ar-Rahman ar-Rahim. Assalamu alaikum means peace and blessings to upon you all. This video is about polymorphism. The basic definitions of polymorphism. So what is polymorphism? If we talk about here, this is the Webster dictionary definition, which is a noun and which says a quality or a state of being able to assume different forms. Very simple, as the name suggests, because we have two things here, poly and morphism. Poly means many and morph actually means form, यानी कि बहुत सारी शक्लें. That is the polymorphism. And in case of, it is a very essential feature of object-oriented language. So when we say object-oriented language, it means we are dealing with what? Objects. Okay, so that means we are talking about different forms of objects. What does that mean? Let me give an analogy. For example, we make a robot, okay, and we say that this robot is a multifunctional robot. It will work as a teacher. This robot will work as a peon. This robot will work as a fighter, maybe. Okay, let's give it an analogy. That means what? That means if this robot is gonna work as a teacher, I have to run a piece of code, a subroutine, a function, which will tell him how to act like a teacher, isn't it? So if the same robot has to work like a fighter, so we have to run a fighting subroutine or a function, which will tell this object, this robot, that how to become a fighter. Similarly, in an object-oriented language, we have different functions for same object, so that our same object behave differently. So as you could see here, polymorphism has two types: static polymorphism and dynamic polymorphism. And in static polymorphism, we have function overloading and operator overloading. Let's first a little bit discuss the static polymorphism. When we say static polymorphism, what does that mean? If it's static, it means we know in advance. That means in compile time. It's actually compile time polymorphism. What does that mean? For example, we have function overloading. You should be knowing what's function overloading. Okay, here I got my better example of the function overloading. So here we have the add function, which is overloaded, okay, and it handles different types of data. Now if you can look here, if you can see the add function, this is the add, again the add function, again the add, again the add, same name, add, four different functions. These are actually only prototypes. I have not written the function definitions. You can understand there are function definitions for these, but I have four add names. That means I'm using same name add for the four functions. Now if you could see here, when I call cout add 5 10, when I call add with the arguments 5 10, that means both integers. Compiler knows that it is this function. Similarly, if it is one float and second is the one is integer, second is float, that means it's gonna be calling this, and both float, so it's gonna be calling this one, and so on. This means compiler knows before running it. That means at a compile time, that which function call to bind with which function definition. This is called as early binding or compile time binding. That is what I said, that we have a compile type binding, but it is a polymorphism because we are using add function to behave differently, isn't it? It can behave differently, the same name, so it is polymorphism. And compiler knows which function to add with which one, so it can do it on a runtime, and before running it, it knows this call should be bound with this. That means with this call, the code of this function will be bound. So we are done with the function overloading. Okay, second thing of it is operator overloading. For example, we have a plus sign. It is already overloaded. I mean, a function is written for it to tell that how to behave, how this should behave. For example, I say 2 plus 4. I'm adding two integers. Actually, a function will be written which says compiler what this plus should do. So when this plus is encountered, compiler actually binds that function to this plus sign so that it can add these two integers. But now what else if I want to add two classes? So I have to overload this function plus, this operator plus, so that it can add me two classes. That means I have to write a function, an operator overloading function, which can be called when, like here I'm adding two integers, when I will be adding two objects or two classes. At that time, that function will be called by the compiler, so that that plus there will not act as a plus of two integers or floating point numbers, but the addition of two classes which may be having different data types. So all those data types will be added together because it will be classes depending on that function. But again, the compiler knows at the compile time that what function to use or what function to bind with that operator. Again, polymorphism, but static one. Now the next thing or the last thing is the dynamic polymorphism. When I say dynamic polymorphism, it is actually not when we do not know the things at the compile time. For example, we have a draw function. A draw function, same name draw function, but it can draw me a triangle, it can draw me a rectangle, it can draw me a circle, etc., etc. But I don't know in advance at compile time which function to bind with this draw function. So I'm saying a draw function, but which function to draw, which function to bound with this draw function, because this draw can draw me the triangle, this draw can draw me the circle. So which function? I don't know, because it is up to the user. He will tell me not at the compile time but at the runtime. He will give a choice. Hey, what do you want to draw? He will say I want to draw a circle. So this draw had to be bound with the circle function. If he says no, triangle, so this draw has to be bound with the triangles function, but I don't know in advance. So therefore, for these situations we use a function called virtual function, which you have to learn. Virtual function which will make it, which will do what? Which will do late binding, which will not bind it at the compile time, but it will delay the binding. That means this draw function, which function to bind with this draw, will be deferred until the runtime. That means when the user will tell us, hey, circle, so a circle function will be bound with the draw, but that will be at the runtime. That's why we say dynamic polymorphism. It's again the polymorphism, isn't it? Because it is the draw. Draw is, we are using the draw function for doing many things, like drawing circle, like drawing triangle, like drawing cartoons or whatever. Now that draw is polymorphism, is implementing polymorphism in many forms, but not at the compile time but at the runtime. Therefore we end up with the discussion that polymorphism actually has three things, and that it could be function overloading or operator overloading, but it is at a static polymorphism because they are bound with their functions at the compile. But in case of many things when we do not know at a runtime what to do, we actually delay the binding and we say, hey, do late binding. And how we do that? By the virtual functions, and that's called as dynamic polymorphism. I hope this will be the good definition and introduction for the polymorphism, but you should be you can comprehend the whole concept if you know the inheritance properly, if you know the function overloading and operator overloading, as well as the virtual function. And one more thing, that's called as function overriding. So I think it's time for you. Don't worry if you don't say thanks, but if you put in your smile, a big smile on a face, that's enough. So take care.